Hello everyone, we are from class of ES1 doing physics assignment FBP0015 about chapter 2 kinematic in one dimension free fall. I am Muhammad Amal bin Swadi.
My name is Alia.
And my name is Sofia binti Ridwan.
Physics is essential in explaining and predicting real-world phenomena. Free fall, governed by gravity and motion laws, is a fundamental concept. It involves objects experiencing acceleration, velocity, and gravitational forces. Studying free fall depends on our understanding of this law and their application in other areas.
So, the objectives of our case study are determine the height of an object with physics formula, which we will discuss later, and students able to prove that value of gravitational acceleration, which is g equal to 9.81 meter per second square, is constant. Lastly, student able to apply physics formula in real-world physical and solving problems.
Drop the Rock has been chosen as title as we use rock as our material. The reason why we choose rock as our material is to achieve the objective of our case study, as rock has small surface area, which will make less resistance acted on it. This will help in solving real-world physical situation problems such as our case study, which is free fall motion.
Next is theory. In physics, free fall refers to the motion of an object under the sole influence of gravity, with no other forces acting upon it. In a state of free fall, an object is subject only to the force of gravity and experience a constant acceleration downward. When an object is in free fall, it is essentially in a state of weightlessness. This is because both the object and the observer are falling together, experiencing the same acceleration due to gravity. As a result, the object doesn't exert any force on the observer and vice versa, leading to a sensation of weightlessness. The downward acceleration on Earth is called gravitational acceleration, which is known as g, and it is regarded as constant at the value of 9.81 meter per second squared. If we take upward to be the positive direction in our reference frame, then g must be equal to negative 9.81 meter per second squared. In free fall, several fundamental physics concepts come into play, such as the firstly is gravity. Gravity is the force that attracts objects with mass towards each other. In free fall, gravity is the primary force acting on the falling object, causing it to accelerate downward.
Secondly, acceleration. In free fall, an object experiences constant acceleration due to gravity. Near the surface of the Earth, this acceleration is approximately 9.81 meter per second square, which is often denoted as small letter of g. This acceleration is directed downward and causes the object to increase its velocity over time.
Newton's law of motion describes that the relationship between the motion of an object and the forces acting upon it. In free fall, the object follows Newton's second law, which states that the force acting of an object is equal to its mass multiplied by its acceleration. In this case, the force is the gravitational force and the acceleration is the acceleration due to gravity.
In this case, the motion of an object in free fall can be described by simple kinematic equations such as S equal to ut plus 1 over 2 at square, where S is the distance traveled by the object during free fall, U is the initial velocity of the object, T is the time taken of the object during the fall, and A is the acceleration due to gravity, which is g equal to 9.81 meter per second square.
Kick.
for the calculation to solve our problem in our case study, we use the formula S equal to UT plus 1 over 2 AT square. By using this formula, U is taken as 0 since the rock starts from rest. Based on the video, we have to find the average time taken for the rock to reach the ground. This is to ensure the value is an accurate value. The value will then substitute into the formula and the given answer will be in meter. The answer shows it is height of a building and a height of a person. Next, these are the questions that is related to our case study in real-world physical situation. Number 1, a €2 coin is dropped from the Leaning Tower of Pisa. It starts from rest and falls freely. Compute its position after 1, 2, and 3 seconds. It already states that it starts from rest, so the U must be 0. And then, we have to substitute the time taken into the formula and the given answer shows it is height. For question number 2, the coin is released 47 meters above the ground. How much time is required for the coin to fall to the ground? What is its velocity just before it strikes the ground? So, based on the question, we can use the formula S equal to UT plus 1 over 2 AT square. This is because the question already gave the S, which is 47 meter, which is known as displacement. Then we substitute the value into the formula and the time taken can be calculated. For the velocity, we have to use the formula V equal to U plus AT because the velocity in these questions refer to the coin fall to the ground, not from the rest. Based on the formula V equal to U plus AT, U is 0 because coin is from the rest and A is positive 9.81 meter per second square and T is 3.1 second based on previous question. So the answer is given in meter per second, which shows it is velocity when the coin falls to the ground. That's all from us. Thank you.